I guess it's time for you guys to ask the typical question, which is when are we ever going to use this? Well, actually, this idea of having a side called a hypotenuse, having this arrangement of sides that we actually know the formula for, this is my blank version, is something that is useful because now that we know that there's a relationship, that lets us work out one of the sides. If we know the other two, we can find the length of the hypotenuse, or as we'll see in a couple of lessons time, if we know the hypotenuse on one of these, we can work out that third side. So the process is fairly simple, although in future years we may even learn some shortcuts. For now, let's just do it in full. The first thing we've got to do is just take our triangle and work out which side is the hypotenuse, which again is always the one that's opposite the right angle, so that's the hypotenuse, and it is the special side that goes by itself in our equation. So this longest side squared is always going to be equal to the other two sides, lengths squared, and added together. So at this point, we've done the first thing. We just write it out. Doesn't matter that there's numbers in there. We just write out whatever we've got. The second thing we do is we simplify as much as we can. Now there's nothing we can do to x squared. So really the x squared just stays here. Although you can leave it out because an equals by itself always means is equal to what we've already got, which is why I complain when people use equals to mean and now something different. But this is 25. And 12 squared, if we know our multiplication tables, is 144, and if you don't, use your calculator. And 25 and 144 adds up to 169. Now, that doesn't help. Obviously, this side is not 169 centimeters long. But the number of that length squared is what has to be equal to 169. So what we need to do is undo that squared. How do we do the opposite? How do we get rid of a squared? Well, the opposite is to use the square root. I hope you are all calling out at your computer screens while we do that. So if we get rid of that squared, we can say that just normal x is the square root of 169. And amazingly for us, if we put that into a calculator, it is exactly the number 13. So x in this case, this length happens to be 13 centimeters. Now, I guess the question should be, will it always come out to be a whole number? Because most of the time when we use a square root symbol, we end up with some ugly decimal. Well, yep, you're right. We're pretty much always going to end up with the ugly decimal. Let's try another one. So again, the first thing we wanted to do was to, I'm waiting for you to yell at me. It's okay. It's label where the hypotenuse is, and remember this is the special side all by itself on the left. Could be on the right, but it's all by itself. The other two sides are the ones that we need to square, and we need to add them together. Now it's just convenient here. I think I've done both of these questions. I've put the smaller number first. It doesn't matter when we're adding two numbers together, the order that we add them doesn't matter. So 4 squared is 16. 7 squared is 49. It doesn't matter. Again, your calculator could jump straight from here to our most simple format possible. But that is 40, 50, 65. And then, well, we know x squared is 65 because remember that's the same up to here till we write something else on the left. So if I want normal x, I need the square root of 65, which we can use our calculator for, and we'll put in the square root of 65 is equal to, and it says something pretty horrible, 8.06225. I'll move that off the screen so I can keep writing it without losing it. So 8.0622577 dot. Well, if we round this off, our original numbers only have one digit of accuracy here. It's only a 4 and a 7. So I don't really want to go to too many decimal places. Maybe we'll say one decimal place. I don't know why the D is missing on this sheet here, but it is one decimal place. Well, we're going to keep the 8, the whole number. We're going to keep the first decimal place. We're going to chop it off here in front of the 6, which means that's the one we look at. And the 6 says, am I more than halfway to 10? And of course the 6 is halfway to 10, so we're going to add 1 to the digit where we chopped off, and we get 8.1. And if we want to write it as x centimeters, then we can actually say that it is 8.1 centimeters. So you guys should, hey, I found where my D is, it's somehow snuck down there. You guys should be able to have a go at the textbook. That'll do for today. I don't really want to make it too complicated if I don't have to, but we'll stick with the textbook. And if you guys could upload an image of the work in your textbook, then that'll at least show me whether you guys are preferring textbooks, Khan Academy, Maths Online, or whether you would rather have the homeworky bit, the actual doing and checking part in some other format. Please let me know.